Hello everybody and welcome back to week 6 hot dog, and we are underway with schedule management. How important is a project schedule? Let me tell you, pretty darn important. You can see that the schedule represented in this chart in the initial stages of the project is pretty darn important. By the early phases, it's the second most important issue in a project next to priorities. By the middle of the project and for the remainder, it is the number one challenge. So keep that in mind. Now, as we look at a schedule, kind of an overview, a high level view, but there are really these pieces going on. First, we're going to select a schedule model. How do we want to build our schedule? And normally we will do it in terms of a precedence diagramming method. So we will take these activities and put them in order of precedence that they should happen. And the path that we're going to use is called critical path method to evaluate that precedence diagramming method. Now, so the first thing we'll want to do is figure out what our activities are. These are the little boxes there. And then create a network diagram. The network diagram really just puts the activities in order. It sequences them, which should come first, which should come second. After that, we'll figure out how much time each path will take. That would be the duration for each activity, rather. And once we have that, we can plug those activity durations into the network diagram and then do network analysis, right? So once we've plugged in the data, we're going to do network analysis. After that, and we're satisfied, we've looked at other courses of action for doing our schedule, bam, we will publish our schedule. And when it's called the approved version of the schedule, that becomes our baseline. Now, I've talked a lot about activities, so if you remember in scope management, we talked in terms of work packages. In schedule management, we talk in terms of activities. So an activity list develops, right? These little boxes. We call them nodes in schedule management. And so just like back in scope, you had the work breakdown structure, and the details were in the work breakdown structure dictionary. Well, here in schedule, you've got a node and all the detail, which are the activities in a list. And we want activity attributes, which are the details in each activity. And I just list some details. It's not in an order of priority. I just had fun making it look like a little red tornado. But these would be examples of things in an activity attributes document that goes with the activities in the activity list. Okay. So after you have the activities and the activity attributes, you can develop that, you can sequence them to develop that network diagram that I talked about. And what we really care about in project management are things like risk. So I'm looking for paths that converge on each other, like B into C and D into C. That's increased risk for me because I have to wait until both B and D are done to start C. The same would be I can't finish until C and F activities are done. I have a lot of tools. I talked about after I figure out that network diagram, which is just the sequencing, I need to add times to them to make my schedule. How long is each activity going to take? There are lots of tools for figuring out how much time it takes to do each activity in the schedule. It's pretty self-explanatory slide. You can find more information online if you want to dive down deeper into these tools. But like I said, it's kind of self-explanatory. It's a good read. Notice that the first two in red are called ROM, or rough order of magnitude. That's going to give you an initial estimate for your activity, but it really isn't going to be your final estimate. You're going to develop that later using things like three-point estimating, bottom-up estimating, etc. Also part of this approach is a data analysis. That includes reserve analysis. Reserves are really a risk management item, but they are discussed in detail in schedule and cost. So they're a risk management item that address schedule and cost issues. So there are two types, contingency reserves and management reserves. Here's the first one, contingency reserves. These are for known unknowns. So the project manager identifies the risk, but they don't know if the risk will actually happen. That's the very definition of a risk. It's an uncertainty. And it has two categories. It's a threat or an opportunity. So because the project manager identified the risk and did the planning, they reported it to the sponsor who owns the budget, and the sponsor says, great, good job. I will give you some money to set aside for a red risk, which would be a threat, or a green risk, which would be an opportunity. Now, the other type was called management reserves in data analysis. And this is for unknown unknowns, project management calls it. So we didn't identify the risk, so we didn't see it coming. We frankly didn't plan it then and have to go explain it to the sponsor and request the money to support the schedule or cost issues that result. It is going to lead to a change request, of course, right? That's for sure. Really want to avoid these situations. As a manager, I generally will set aside about 12% of the proposed budget for management reserves without sharing that with the team. Now, as I walk through this, most schedules we've ever known fall behind. That's just a reality of life. So project management offers us a couple of ways to address that. One is called fast tracking, and the other is called crashing. So fast tracking is basically taking two activities that are normally in sequence and moving them to in parallel. Well, that's going to create additional risk. There's a reason we scheduled these activities to happen in sequence, but sometimes they can be done in parallel. You can make up some time. Crashing really trades. So crashing is going to shorten the schedule, but it's going to cost you money. And that's also going to increase risk too, because you can add more people to a certain activity or two. Now, there's also the law of diminishing returns. I can't keep adding people and keep shortening the schedule. At some point, people get in each other's way. So you'll see the picture on the bottom. It shows crashing and fast tracking. There are other things to watch out for, right? Others, especially a vendor, may try and cut scope or quality, right, to speed up the schedule. You want to watch out for that as a project manager. But the formal power you have is to crash or fast track the schedule. Now, as we're making the schedule, right, we're filling in this box. So at first, we have our nodes, A, B, C. Those are all nodes. Then we put them in an order that was called a network diagram. There were no numbers in it at the time. And then we begin to figure out the duration right here in the middle. That's how long each activity will take. Once I do that, I plug those in to my nodes, and then I can begin to figure out the early start or the early finish at the top, or the late start and the late finish at the bottom. And I do that to eventually determine the total float. When I've determined the float, any activity with a float of 0 is on my critical path. It has no extra days. It must happen on time. So I fill out this box by doing a forward pass first, right? So I can start activity A on node A on day 0 or day 1. It's up to me. And it's an 8-day duration, and you can see that it'll end on day 9. Well, that means I can begin activity B and C on day 9. B has a 12-day duration. It has an early finish of day 21. C began on day 9, early start, had a 16-day duration, and has an early finish of day 25. Now that continues. Notice conversion is dangerous. So like take activity H. It has to wait until D and E are both available. Well, D has an early finish of day 35. E has an early finish of day 38. So H cannot begin until day 38. Now after the forward pass, I'm going to do a backward pass, and that's going to fill in my numbers on the bottom of these boxes here. So I take the early finish of the last activity, drop it down, and then subtract the durations going backwards. Notice if it's day 64 is the late finish, LF, I'm going to subtract 12. I get a late start of day 52 for that activity. But this is the opposite of convergence. I actually goes out to G, H, and F. So they must have a day 52. So the late start here becomes the late finish in each of these activities. Okay? And that would fill in the backward pass. And then, of course, notice to determine my critical path, I can do either the late start minus early start or late finish minus early finish. Always gives me the same answer. So I end up with 0 float for A, 3 days float for B. That's considered a benefit to a project manager. I didn't pad time on B. It just ended up with 3 days of extra float because it's not on the critical path. So the critical path ends up to be A, C, E, H, and I. Here's that box that is expanded with the definitions for you. Pause and review it at your leisure, but we've talked about it. On the forward pass, we figured out early start. Well, first we figured out the duration for each activity. Then we figured out the early start and the early finish on the forward pass and the late finish and late start on the backward pass. Here's a quick example of how it might work. I can start with day 2. I figured out the activities, put them in a sequence called a network diagram. Then I added the durations for each. After that, I could have started at 0 or 1. I decided to start at 1. Doesn't really matter. And I start with activity on day 1, add 2 days, and I'm going to end or early finish on day 3. That becomes an early start to 4. I'm just going to scroll through. You can do the math yourself. But notice now we get down to activity F. What's the early start there? Well, it depends, because I have to wait until I figure out the forward pass for E also. So C and E are converging, and I have to wait until both are done. So let's see what that looks like. Well, now I have a day 10 of an early finish for C and a day 7. So F really must wait to start, or an early start of day 10. That makes sense. I add 2 days, and the whole project ends in 12 days. I drop that, and that's the end of my forward pass. Now I'll start my backward pass, where I will drop 12 down and subtract instead of adding the durations. So that's my late finish, minus 2 becomes 10. That's my late start of activity F, and 10 goes into my other activities. I continue the backward pass, but what must go to the late finish for A, right? I have to wait until I figure out D and compare that and take the smaller of the two in the backward pass. That wraps that up. Then I figured out late start minus early start, or late finish minus early finish. Those give me my float, and with that I now know my critical path. That's it. A couple of slides here to pause and review for Agile and how Agile determines it. Okay, let's take a break. We'll come back with management and leadership portion.